recording started. So I'm going to try and utilize the white space board again tonight to kind of help us get through some of this stuff. I am going to switch my audio to that one, but I am going to do some share screen stuff. And so hopefully I can make all this work where I can get it to like pick up the I can get it to pick up the white screen. I'm going to ask you guys to utilize the chat if you have questions. I do have that pulled up so that I can see it over here off to the side. Hopefully it will, you know, last. I will say the internet here at my house has been a little spotty today. If we get dropped, I will try to get back in just as quickly as I can. So like, don't leave. I will get back in just as fast as I can, and then I'll just have to upload it in 2 sessions. I'm hoping I'm not going to have to do that. But you know, you never know. So, okay, I'm going to switch my audio. So I'm going to try and see if we can get this to switch over to that white screen real quick. So hang on and let me try to do that real quick. Okay. Ooh, turn that down. Okay. Try that again. Okay. So did it go to the white screen with the board? Yes. Okay. It's gonna be a halfway decent night, hopefully. Okay, so now what I should be able to do, and I'm trying my darndest to try and make sure that I don't get a whole lot of feedback. I don't know how well that's going to work, but you know, we're going to try. Okay, so here we go. Now, in theory, okay, so with the chat, are we now looking at the PowerPoint? Amazing. Okay, maybe we can make this work. Okay, there we go. Okay. So we got through section 3.1, I believe, last time when we did, because I wanted to have kind of a nice, clean break. I do remember us discussing doing the GPA problem with the biology and the stats class and the basket weaving and all that good kind of stuff. What we'll start to get now is what's called measures of spread, okay? And the concept here is you can have 2 data sets that have the same mean, median, and mode, but that does not mean that the values are similar, okay? So for example, if I have 2 class periods and they both took a test, I can have that both class periods have a mean of 75, a median of 76, and a mode of 74. Okay, so they're all kind of right there together. However, the data may not be similar. And by that I mean, one class may have grades that everything is from 70 to 80. And certainly with the grades between 70 and 80, they would be similar in having the mean of 75 and a median of 76 and a mode of 73 or 74, whatever I said it was. And that's fine. The other thing, though, is you could have grades that spread from 50 to 100. Okay? And so with those grades ranging from 50 to 100, I could still have a mean of 75. That would still land kind of in the middle of that pack. And a median of 76 and a mode of 74. So just having mean, median, and mode doesn't necessarily give me a full picture of what's going on, okay? So we start to talk about measures of spread, because certainly if I know how spread out a data set is, that's also going to give me some indications, because I'll be able to tell based on certain measurements if things are really, really close together or really, really far apart, okay? So the first one that we're going to talk about is the range, okay? Now, range is just biggest minus smallest. Okay? If we were going to look at this particular data set, we've got the average monthly temperatures in Fahrenheit for San Francisco. We looked through that list. 63 is the highest in September. 51 is the lowest in January. So if we subtract those two, we get 12. So the range for this data set would be 12. Now, range is super easy to find because you are only needing two numbers. You're going to subtract them, nice and clean, okay? The problem is it only involves two data points. It only uses the top and the bottom values, or the highest and the lowest values, which means it's not always going to be the best at talking about how spread out something is, okay? I go back to that example of the test scores. If only one person made a 50, but everybody else was up in the 70s, okay, or 70s and 80s, and only one person made 100, and there was a gap, okay? So we had this low grade of 50, and the next lowest grade was like 70. And then we had up through like the 80s, 85 maybe, and then there was a huge gap up until 100. Well, it sounds like my range is 50. But there's really, and it is, but the thing is that that's only two data points. And the bulk of my data is actually right there in that 70 to 80 grouping. But the range makes it feel like it's a lot bigger, okay? Now, we have ways to delve into that, okay? Now, so when a data set has a small amount of spread, like that example that we just looked at with the San Francisco temperatures, okay? We had that low of 51 and that high of 63. It's not a whole lot of wiggle room in that, okay? Most of the values are pretty close. When a data set has more spread out, okay, then the data are going to be farther away. Now, there's this thing called variance, and this measures how far the values in a data set are away from the mean or the average, okay, on average. Now, this calculation is done slightly differently for populations and samples, okay? So we're going to look at population variance first, okay? Now, what we're going to see here is there is going to be the formula that they have, and then there's going to be the prettier looking one. Okay, well, excuse me. There's the pretty looking one, and there's the easier one to work with, okay? So we have that the population variance is this sigma squared equals the summation of xi, which is the value, minus the mean, and then you got to take that subtraction answer and square it. Then we're going to total them all up, and then we're going to divide by n, okay? Now, the less pretty looking formula, but the one that is easier to work with, okay, is going to be, and I'm going to switch here in just a second. I'm going to get it written down first. Okay, so I'm going to stop the share. Okay, so let me get this to where that lovely glitter is out of the way. Okay, so what we've got is we've got to take each of our x values and square it. And then we're going to subtract. Now, this says I've got to add up all of the x values first, and then I'm going to square it. Okay? So we're going to plug that in, and then we've got divide by n, and then we've got this big divide by n. This chunk right here is kind of taking the place of where they had that mu or that mean notation in the other formula. Okay? Now, the reason that I say that this is not as pretty, looks like I've got a lot more symbols in here, but I've actually got less math, okay? Because the only thing I actually have to do with the values is square them and have them, okay? That's it. So the example that I'm going to do for this, okay, I'm going to try and get this to where I can have that formula still sitting up there, okay? This is going to be number 2. Ooh, it's going to be number 2 out of the packet. Now, I'm not going to depend on you knowing the packet, okay, for this. But the other thing is that this needs to have an edit to say population variance. Okay. Now, I'm going to come back and do population standard deviation here in a second with this, okay? But for right now, our numbers are 18, 6, 18, 12, and 24. Okay, so what we're going to do, I'm going to make a table. These are my x's. And then I'm going to have x squared. So 18 squared is 324. 6 squared is 36. 18 squared is 324. 12 squared is 144. And 24 squared is 576. Now, I need the totals. So 8, 14, or 8 and 8 is 16, and 22, 3, 4. So I've got 78 as my total. Okay, and I'm going to add over here, so that's going to be 10, 20, and 4. 2, 4, 5, 6, 7, 8, 9, 1, 4, 13, 20, 2. So 2, 5, 6, 7, 8, 9. And I've got 1404. Okay, so let me see if I can move this over just a bit so I can see that a little bit. Okay, so now plugging this into our formula, I need the total of the x squareds, which is 1404, minus, set of parentheses, the total of the x's, which is 78, squared, over, now n is the number of points, so 1, 2, 3, 4, 5, and then over 5 again. Okay, so now I'm going to come down here and work with this formula a little bit. Okay, so 1404, 78 squared, oh, got my calculator, is 6,084 divided by 5, divided by 5. So now I have 1404 minus 16.8 over 5. $187.2 over 5. This is our variance. Okay, and the notation for that is this little sigma, which is an O with a little line on the top, squared. Okay, now I'm going to go ahead and handle how to do standard deviation. Okay, so standard deviation is sigma, which is the square root of sigma squared, or the square root of the variance. Okay, so if we're going to go back down here to what we had, okay, I can say that the standard deviation which is going to be sigma, is going to be equal to the square root of the 37.44 that we just had. Separate this. And that's going to be 6.12. And I did round that at 2 decimal places. Okay. So, and again, this was population. Now, and I'm going to leave that up there for just a second. Now, what I'm going to do is I want to draw you a picture of kind of what standard deviation, because standard deviation is what we use more often than we do variance, okay? And honestly, when I talk to you guys about how to put this on a calculator, it's actually going to show you a standard deviation and not a variance. So you would actually be working this backwards, where you would be given sigma, and then you would need to square it, okay? Variance is nice because it actually says it straight up. It shows you that that variance value is sigma squared. So if you have standard deviation, which is just plain, you square it to get the variance, okay? Now, the concept behind this, okay, and I'm going to try and get a picture here, is you have the mean, okay, and then you've got some data points that are higher. Let me see if I can find a better color. I think maybe that's a little better. So you've got some of these data points that are higher up, okay? And then you've also got some data points sorry, y'all, I'm working through all my colors, trying to get colors. Okay, now the concept here is I want to figure out, okay, and the concept here is these kind of purpley color, grayish color that's over here, those are above the mean, okay? So thinking back to like a test score idea, if the mean was 75, these would need scores like 80 or 78, stuff like that that are above. These kind of orangey red colors are below, okay? So the concept is, if this is a distance of say 3, and this is say 4 under for this next orange piece, and then this next purpley gray piece may be 5 above, and then this may be 1 below, and this one is 1 above, and this one is, 7 under, whatever it is. The concept is I want to find the average distance. Okay, now the problem is if I use +3 and -4 and whatever like that, going to happen is all of those positive and negatives are going to cancel each other out. So we have to come up with a way, or mathematicians have to come up with a way to deal with this. Well, there's two options. One is we can do absolute value. Absolute value takes anything negative and turns it positive, keeps anything positive, and stays positive. Absolute value is not easy to work with within the confines of the math stuff, okay? So the other way is to square things, okay? So if you take a positive number and you square it, it's still positive. If you take a negative number and you square it, it's positive. Now, the concern is that if I square all these numbers and then I add them up, I need to get back out of that squaring thing, which is why for standard deviation, they bring back in that square root symbol, okay? So, that's the concept behind it, is we're just trying to figure out what this average distance is that we have something away from the mean. And we have to do it in a way, or in such a way, that we don't have the positive and negatives cancel each other out, okay? So, now then, we'll go back to our PowerPoint. Okay, so now, sample variance, okay, with a sample, because technically a sample can have all the way up to just not including. So if I had, my population was 100, technically the sample could be 99, okay? Not that we would ever do that, okay? But they could, okay? But the thing is, okay, in sample stuff, the last value has to be the one that brings everything into balance, okay? And since I don't have that, I need to adjust it in our formula, okay? So what they do here is, instead of dividing by n down here on the bottom, okay, they divide by n minus 1. Now, the other thing is, notice the use of the letter S over here. Third alphabet, we know we are back over in sample stuff, okay? Now, I'm going to show you that other alternate formula for what it's going to look like, okay, if you don't want to do kind of this one that they've got going on here, okay? So let me pull back into our lovely setup. Sorry, y'all can see my messy desk here. And so for this one, okay, so notice, very, very similar formula. The only difference here is we have a lowercase n here, which is still the number of items in the set, and we have an n minus 1 down here on the bottom. Okay, so we're going to look, this is going to be number 1, and again they want sample, but this time they want sample, but they want variance and standard deviation. Okay. So our numbers are 16, 34, 24, 20, 12, and 36. Okay, so I'm going to bring this down. Let's see if I can get my lovely little spotlight to where it's not covering stuff up. So, same gig. Now then, just for reference, okay, we do have a test next week. I will be giving you this formula. Okay, I will also give you the other, okay? So I will provide you with a bunch of those formulas. Okay, so I'm going to do 16, 34, 24, 20, 12, and 36. Okay, put this down. Okay. So 16 squared, 56. 34 squared is 1156. 24 is 576. 20 is going to be 400. 12 is 144. And 36 is 1296. And again, we're going to total these up. Okay? So it's going to be 10, 22, 2, 3, 4, 5, 6. So over here, I've got 6, 2, 10, 12, 19, 10, 17, 19, 20, 32, 3, 5, 6, 11, 15, 16, 17, 18, 2, 4. I'm going to double check that now. Oh, I think I added one where I wasn't supposed to. It's supposed to be 3828. Let me double check. Yeah, 3828. Okay, so following formula. Need the total of the squares minus total of the x's. It's 142 squared over n, 1, 2, 3, 4, 5, 6 over 6 minus 1. Okay, so 328. Oops, sorry. Okay, so we've got 3828 minus 2164 over 6 over 5. So I've got 38, get this down. Okay, so we got 467.5, and I am letting my calculator take a lot of this. It have and handle. Okay, so 93.4666 repeating. Okay, and if they're going to do, and again, this was s squared, which is a variance. Okay, so now if I want to do my standard deviation, I'm going to do square root of what we just got. Okay, I'm going to square root of this. And again, this one I did round. Okay, I rounded this one at 2 decimal places. Okay, now let me talk about how to put this on a calculator. Now, I'm going to discuss how to put this on the TI-80 series, okay? Does anyone, let me ask this, does anyone on here have the TI-30 series? Let me post this in chat. Okay, and the 80 series are going to look like this. Okay, the 30 series are smaller.
Mom, can you hand me some notebook paper?
Okay. And I'm going to talk about how to put this on the 80s. Okay, so with the 80s, you're only going to have to deal with the original data set. Okay, so the original set of numbers. I'm going to move this over. I'm going to try and get this to where we can kind of see what's going on. Okay, hopefully this is not going to have too bad of a glare on it. Okay, so what you're going to do is you're going to hit this stat button. Okay, so you're going to hit stat right here. And it should come up and say edit. Okay, once you have this, you're going to press enter. Okay, now what should come up is, and let me see if I can get this to kind of zoom in here kind of close for a second. Okay, what you should get is something that says L1, L2, L3, potentially out like L5. You may not quite get all of those, okay, but you should get most of them. Now, if your calculator has data in it, like mine has some data stuff in here, what I'm going to do is I'm going to press the up arrow button until I have the L1 highlighted in black. I'm going to press clear and then the enter button. And that's going to clear that data out. Okay, Morgan, that'll be fine. Mine, I think, is also an 84, so it's going to be the same button presses. So now, in this L1 list, you only need to put these 6 data points. Okay, so I'm going to zoom in again. This is great fun, y'all. Okay, so what I've done is I've just put the 6 data points, okay, which means I really wouldn't have even had to make a table because this could have been done straight from here. You do not have to put them in any particular order, okay? So you just need to put in the particular data points. Okay, so we've got those in L1, and now we're ready to start doing our math with this, okay? And I'll try and get the glare off of here just as soon as I can. Okay, there we go. So now, what I'm going to press is we're going to press stat again, and then we're going to go over 1. So we're going to arrow over 1 to calc, and we're picking this first option, 1 bar stats. And you're going to press enter enough times until it pops answers up to you. Okay, when it pops answers up to you, because you'll see all of them pop up. Okay, now, some of the stuff that's on here, Terry, yes, I am recording this, and I'm going to go through this stuff again. Okay, so I'm going to be talking about how to do this several times tonight. Okay, so after you put your data in, and we did that stat over to calc, let's talk about the stuff that comes up on here, because some of this will be helpful when you're doing stuff. So I'm going to try and do this without making y'all absolutely just motion sick. Okay, so the first thing we've got up here is X bar, and that is, sorry, I'm trying to move up here. Okay, X bar is the mean. Okay, so even though this data set did not ask us for the mean, we still get it. Okay, so we have 23.666 repeating. Okay, now it will give you both the total of the X, 142, which we already knew, and the total of the X squareds, okay, which is that 3828. Hence, we had that one there. Now, here's the deal. Calculators do not know whether this data set that you put in is a population or a sample. So it is going to calculate both. So this SX is your sample, okay? And this is that 9.67. Guys, that is that same answer that we just had over here. Okay, so it's going to do the same answer. Now, the sigma is going to be the population one, okay? Because again, the calculator doesn't know which one you need. Now, it will also tell you the number of data points, so 6. It will tell you the minimum, which was 12. Q1, we're going to talk about that a little bit more here in a minute. It will give you the median of the data set. Q3, again, more on that here in a minute. And then the max. Okay, and that is all the information. You can scroll kind of up and down through these as you need them. Now, the calculator will only give you the standard deviation. Now, it is your job to make sure that you read the problem and know whether or not you need the sample, which is S, or the population, which is sigma. Now, it will not give you the variance, but remember, okay, standard deviation is the square root. Now, we can easily move that over. You can take this 9.67, and if you squared it, you will get back to this 93.46 number. Okay? So if they ask you for variance, you're just going to take your standard deviation and square it. Okay? So now, I'm going to pull back up. Okay? And I'm going to have us walk through that number 2 problem. I'm going to put our data set up here. And again, for this one, we were doing population. And our data set was 18, 6, 18. Move this over a little bit. And we don't need that formula. So we're going to use a calculator. I don't want confusion. 12 and 24. Now, just FYI, what we had figured out. We had gotten this. These were the answers that I had given earlier. Okay, so now let's walk this through on our calculators. Okay. Slide and see if I can get that lovely dot to go away. Okay, so I'm going to cover this up for just a second. So I'm going to hit stat. Okay, so we're going to hit stat. We're going to hit enter the first time. Now again, I've got stuff in this list. I'm going to go up. Move this up so you can see it. I went up to L1 and highlighted it in black. I'm going to press the clear button and the enter button down here on the bottom corner. And that is going to clear that list out for me. And then I'm going to put in this data set. So 18, 6, 18, 12, excuse me, and 24. And then we're going to hit stat. we're going to go over to Calc, and we're picking that first option. We're going to press enter enough times until it pops answers to us. So again, it gives us the mean. Now notice, with this one, we were talking about population. So that means that I need sigma. So that's going to be that 6.118, which I told you I had rounded, so that is 6.12. Now, if I take that, and I'm going to go a couple more decimal places, so 6.1188, and I square it, that's going to get us back to that 37.44. Okay, so again, we're kind of having to work a little bit backwards with the calculator because it will only give you standard deviation. It will not give you variance. Okay. Okay. Hopefully everybody kind of tracked and followed with me there. I'm going to switch us back to our PowerPoint. Okay. Okay. So the next thing is it says, why do we divide by n-1 on the sample deviation, on the sample variance and the sample standard deviation? Again, it's because we don't know what all the values are for that population, okay? So when we do that, we need to give ourselves a little bit of wiggle room. So dividing by n-1 gives us that wiggle room, okay? So now, standard deviation, which we've already handled, is just the square root of the variance, okay? And then, so again, we've seen that standard deviation is the square root. If you're given square root, then you just square back up to get to variance, okay? Now, there is a slide in the PowerPoint that discusses how to put your stuff into L1, okay? And then how to do one-bar stats. Notice here it talks about that S is the sample standard deviation and sigma is your population standard deviation, okay? Very important to make sure that you are telling the difference between those two, and make sure you know which one you need to give, okay? So, now then, we talked about last week about something being resistant. Resistance says it doesn't change a whole lot based on extremely large or small values. Standard deviation is not resistant. If you have an extreme value that is extremely high or extremely low, by comparison to the rest of the data, it will affect standard deviation drastically. Okay? Now then, one of the things, sometimes we don't have the raw data, okay? And we are given a frequency distribution, okay? And so what we are going to talk about is how to do grouped data or standard deviation, and we're going to do it with a calculator, okay? So we are going to hinge this onto a calculator. There are ways to do this, and I will put the formula, okay? I will provide the formula, okay? Let me write it down real quick, and then I'll pull it across. And it is slightly different, but we are going to talk about how to put this on a calculator. So hang on. I'm going to get... Okay, so let me stop the share. Okay, so if you were going to have to do this by hand, and this one would be, sorry, let me switch this up here. This would be for sample, okay? The X's here are the midpoint, okay? F is the frequency. So it is very similar to, and sometimes they do, which one they do. They do it this way. So you've got square the midpoint and multiply it with the frequency. So there's an added step of getting this multiplication to happen, and then that total. Here, instead of just the X's totaled, you have to do X times F, and then total that, and then square it. Like I said, we're going to rely on the calculator to help us out with this. So I'm going to put the example on here. So I'm going to write up our example on here. And then we're going to talk about how to put this on a calculator. Now, there is a little bit of math that we are going to have to do. So this is 0 to 0.9, 1 to 1.9, 2 to 2.9, 3 to 3.9, 4 to 4.9, and 5 to 5.9. We have 25, 19, 18, 17, 14, and 11. Okay. Now, the only set of math that you're going to have to do with this is you are going to have to find the midpoint. Okay. Now, remember to find midpoint. You take the lower limit plus the next lower limit, add them up, and divide by 2. So this would be 1 plus 2 divided by 2. At this point in time, I'm just going to follow the pattern. Okay. Now, this is going to be a little backwards in our table, but when we get ready to put this on our calculator, our midpoints are going to go in L1. Our frequencies are going to go in L2. Okay. Okay, so back on my calculator. Let's see if I can bring this over here. I'm going to hit Stat. And I'm going to hit Enter. Again, I have data in L1, so I'm going to go up and highlight L1. I'm going to press Clear and Enter, and that's going to clear it. Now again, I've got to put my midpoints here. So 0.5, 1.5, 2.5, 3.5, 4.5, and 5.5. And then in L2, we're going to put our frequencies. So 45, 19, 18, 17, 14, and 11. So I'm going to bring this up so you can see it a little bit better, maybe. So I've got my midpoints in L1 and my frequencies in L2. Okay. Now, when we get ready to do this, the only difference here is I need to link these two things together. So when you hit Stat, we're still going to go over to calc, and we're still going to pick the first option, okay? Now, here's what's different, okay? Right now, it shows us that our list is in L1. But notice it says frequency list, okay? This is where we need to get it to say L2. Now, on these calculators, L2 is going to be down here. On my calculator, it's written in blue right here above the 2 button. So I've got to press the blue second button and then the number 2. Okay, and that is now going to put L2 in my frequency list. This is now going to pair those 2 things together. And then I'm going to finish pressing enter. Now, all of this is going to read the exact same. Okay, so we've got the mean is 2.25. They've got the total of the, now, this total of the x's is actually the total of xf, okay, in a formula. The total of the x squared would actually be x squared f in that formula. We have a sample standard deviation and a population standard deviation for this one, okay? We have the total number, which is 124, and then you're not going to need the rest of these, okay, because this is grouped data. We really only need like from here up, okay? That's really all we need for that, okay? Now, the only thing that I will warn you of is if you are going back to do a regular data set, okay? So if I'm going to go back to stat and enter, okay? And I'm going to clear out that L2 list, and I'm going back to another data set, and I'm just going to make some stuff up here. Okay? If I'm ready to go back to a regular data set, and you go over here to calc, please do not leave the L2 in here. You need to clear that out, because otherwise what's going to happen, if it's still in there, it's going to come back and go, I can't do this, because it's looking for that L2 list that's not there. Okay? So if you only have one set of data, make sure that you don't have that L2, that you only have that L1 list given. Okay? And then it'll process through. Now, if we get to test next week and somebody's going, I don't remember how that works and whatever, I'll kind of walk you through that, okay? I'm not going to walk you through how to find the answers, but I'll walk you through kind of how to process through that, okay? So, this particular problem that we just did, if you're looking in the stuff, this would have been number 7, okay, in sample sets, okay, if you were following along with that, okay? So now, back to the PowerPoint. Okay. Okay, so we talked about how to put this on a calculator. Now, the next thing is going to be what's called a bell-shaped histogram. Okay, bell-shaped, we talked about, is symmetric. Okay, bell-shaped is now going to come back. And we're going to deal with bell-shaped quite a bit here. So, there is this rule called the empirical rule. Okay? And what the empirical rule says is that if you're on a bell-shaped curve, you can use these empirical percentages. Now, what it says is if you have a bell curve with the mean at the middle, okay, so right there on that highest peak, and you go 1 standard deviation up and 1 standard deviation down, between those 2 values, approximately 68% of the data is in that range of values. If you go another standard deviation up, so now you're 2 above, and you go 2 below, okay, so you go another one below, so you're 2 up and 2 down, then approximately 95% of the data will be between those 2 values. And if you go a third one up and a third one down, then all or almost all, it's actually 99.7%, will be within 3 standard deviations of the mean. Okay? So, now then, we're going to look now then, I'm going to draw another, okay, we'll do a couple of examples here. Okay, so, we go back to here. Okay. Now, here is what they tell us, and this was on a data set. So they said the mean was 77, and the standard deviation was 8.
Mandy. Thank you.
Okay.
I'm good. Nah, man. Yeah. I will. Thanks, bro.
Okay. So
Appreciate
now
it.
then,
Thank you.
what we do with this, okay,
All right. Yeah, everybody's good. Preston's improving.
slow people in my house. Okay,
It means
so
a lot. Thank you.
middle of this is going to be
I'm
77.
good. I talked to everybody. I actually
Okay.
need to go.
Now,
but I'll call you tomorrow.
I'm going to draw
All right.
3 lines above,
We'll get to it.
and we're going to add. So this mark is going to be at 85.
Yeah, you can text me. You can text me. I'm up.
Okay, so I did 77 plus 8 and got 85. Next one up
Okay.
is going to be at 93. Okay, so again, all I did was add another 8. And then we're going to go another set up, and we're going to add another 8. Okay, and then we're going to repeat the same thing down on this other end. So we got 1, 2, 3. Okay, subtract 8, and we're going to be at 69. So that was 77 minus 8. And then we're going to subtract another 8 and be at 61. And we're going to subtract another 8 and be at 53. Okay. Get all this in here. Okay, so now they ask and they say, what percentage of values will be between 53 and 101? Okay, so.
You're looking good, bro. You're doing good.
Okay, I'm going to go ahead and draw this center line just so we have it. So 53 is 1, 2, 3 down, and 101 is 1, 2, 3 up. So we are 3 standard deviations away. Now, according to the ruling, I'm going to move this down.
Right, look.
Okay, if you were 1 standard deviation up and down, that was 68%.
He just came here.
Yeah, I gotta get on this TV.
If you're 2, it was 95%, and 3, it was all or almost all. Okay, so since we were at 3,
I have a meeting. I get to.
it's going to be all or almost all. Okay, now another question that they asked on the same one is between what 2 values does 68% lie? Okay. So the second style of question they can ask is between which 2. Looking back down here at our cheat chart, one standard deviation is 68%. So that means I need to go 1 down and 1 up. Okay, so between 69 and 85. So this would be 69 to 85. So again, they can ask this question 2 ways. One is they can give you 2 values and ask you to go between them. The other one is they can ask you to do the percentage and then ask you to give which 2 values that's going to happen. Okay, now the other thing that's going to happen with this, okay, is, and I'm going to redraw this pretty little chart here. Okay. So we can get this in. Okay. Now, I will not do this to you guys, okay? But you may encounter it in the homework, okay? Now, if you remember, 1 up to 1 down was 68%, okay? That means there's 34% in each of those spots, okay? Now then, the next 2 said that it was 95%. Now, that is a difference of 27%, and that has to be split evenly. So this is 13.5 and 13.5. Now, what they don't tell you, okay, is this next section is 2.35. I'm gonna write that a little better up here. Okay, I'm gonna move this over so you can see a little bit better. Okay, and then in this last final section is 0.15, and this is also 0.15. Okay, now, the reason that I say this, okay, is the next example that we're going to do, which is number 8 out of the setup, out of the program set, okay, says we have, they're talking about the birth weights of children. We have a mean of 35.41 and a standard deviation of 8.52. Okay, and it says assume that they are bell-shaped. Now, if we talk about this on our number line, okay, and kind of getting our bell shape in there. And I realize my bell curve looks really crappy right now. Okay, we're going to do 3541 plus 852. I'm trying to write this sideways. And I'm going to add 852 again. And again. And then I'm going to take 3541 and I'm going to subtract the 852. Okay. Now, this one asks, the first one asks, what percentage is less than 4393? Okay. Now, the reason that I won't do this to you okay, is for this type of a problem, it's not going to be 68.95 or all or almost all. Okay? You're going to have to add up the percentages that you need. So for this one, I have this first little square over here is 0.15. The next one is 2.35. And again, this is based off of this chart up here. 13.5, 34, and 34. And when you add all of that up, you get 84. Okay, so that is 84%. Okay, now, the only other thing that I've seen them do is from a question like this, okay, and they told us that there were 607 babies when they did this, is they want to know how many babies is that, okay? In order to figure that out, you would take the 84 in its decimal format, and you would multiply it by 607. Okay, so if they wanted you to state the number of babies that weighed less than 4393, I took the percentage that we found, 84%, in its decimal form and multiplied by the 607, which was the total number of babies that they told us that there were. And we can't have partial babies, so round appropriately. Okay? Now, they could also ask you under the same heading, okay, they asked us to also do greater than 1837. Okay, so this is just a different set of spots. So that's going to be 13.5, 34, 34, 13.5, 2.35, and 0.15. Okay, now this big broken down chart, guys, if you look up empirical rule bell curve, it will come through and tell you that, okay? And I get 97.5. Okay? And again, if they wanted you to then figure out the number of newborns who had that percentage. Okay, we would do 0.975. Okay, I'm going to show you that over here. I would take 0.975, which is the decimal version of my percent, times that 607, and I got 591.825, which would go to 592. Okay? And they can, again, do other ones where they actually do, like, between this number and this number. But, again, that's all coming out of this broken down chart up here. Okay? And you can find one of those through, I mean, just Google search empirical bell curve. I don't know if I may have one in my PowerPoint as well. No, I don't. But you can find one of those fairly easily. Okay. So now, there was a guy named Chebyshev, and what Chebyshev said was, I want to be able to work on any data set, okay? I don't want to be restricted to not everything is a bell curve, so I don't want to be able to do it. So Chebyshev decided that he was going to come up with a rule that would work for any data set, okay? So what Chevy came up with and said, and first off, I'm going to have to adjust this formula. This formula is not quite right, and I'm going to rewrite it, okay? So let me switch over and do that. Okay, let me switch this. Okay, so here is what that formula should look like. Okay, so Chebyshev says at least this much. So he lowballs it. It could be higher than this. Now, the only other restriction is K can't be 1. Okay, because if K is 1, 1 squared is 1, 1 divided by 1 is 1, and 1 minus 1 is 0. Okay, so for example, if K was 2, so at least 3/4 of the data is within 2 standard deviations. Now, Chebyshev's cannot do like what we just saw with that example with the babies, where they can go like 2 up, 3 down, something like that. His has got to be evenly done, up 2, down 2. Okay? Okay. So now, let's take a look. I'm going to look at an example problem for this. Okay. And so for this example problem, they tell us that the mean is 77 again, and the standard deviation is 8. Okay. And this is actually number 5 if you're looking at the worksheets. Okay. And it says, if we do not assume that the histogram is bell-shaped, at least what percentage? Okay, now, I'm still going to have that center line at 77. And then we had 85, 93, and 101 going up. I'm going to make this bar a little bit bigger so that you know it's the mean. And then coming down, we had 69, 61, and 53. So they want to know what percentage is between 53 and 101. Now, we are 3 standard deviations both directions. So K is 3. So now, formula said, so this is going to be so at least 8/9, or if you convert that into decimal and then a percentage, you're going to get 88.9. Okay, so at least 8/9 or 88.9% is between those. Now, remember, if this was empirical, that would have been all or almost all. Okay? So, now, the last thing that we've got to do out of this section, okay, is this thing called a coefficient of variation, okay, or CV. And this basically tells us how large the standard deviation is by comparison to the mean. What this allows you to do is compare data sets whose stuff is in different units. So if you were doing something like SAT scores, which are on a scale of up to 1600, versus ACT scores that are only on a standard, or that are only on a scale of up to 36. You can't really compare those two things. So CV is standard deviation over the mean. Now, this could also be S over X bar. Okay, so I'm going to switch out here and go back over here. The idea is it's standard deviation over the mean. Okay, so now the problem that they give us is we've got a National Public Health Survey study that the mean height for men is 71.6, with a standard deviation for our men is 5.3. Now, we have the mean, this was height, weight, okay, is 197.2 with a standard deviation of 41.8. Okay, so they want us to find CV for the heights. Okay, so that's going to be standard deviation 5.3 over the mean of 71.6. And when we divide that, okay, we get 0.074. And I did cut that at 3 decimal places. Okay. Then they ask us to find the coefficient of variation for the weights. So that's going to be the standard deviation of the weights, which was 41.8 over the mean, which is 197.2. And this was 0.212. Now then, they ask which one has a greater spread. It's whichever one of these is bigger. So it's going to be this one. Okay? So the weights are more spread out by comparison to themselves than the heights part. Okay? So hopefully everybody's okay with that. So now, let me go back to our PowerPoint. And we're going to move into the last section of this chapter, which is 3.3. Okay. And we are going to talk about measures of position. Now, I'm going to go back to this idea of the SAT versus ACT scores here for just a second. If you scored in the top 10% on the SAT, and you were also top 10% in the ACT, those two scores are not going to be the same, okay? Because that might be a score of like, I don't know, 1525 or something like that on an SAT because it's out of 1600. But that top 10% score may look something like 34 on that scale of 36. So there's got to be something that tells us that both that score of 1525 and a score of 34 were both a top 10 score or a top 10% score, okay? So there's this thing called a Z-score, okay? Now, the question they pose is, a man is 73 inches tall, a woman is 68 inches tall. Who's taller? Now, obviously, comparatively, the man will be taller. He is 5 inches taller than she is. But men are also taller on average than women, okay? Overall, men are taller than women. So the question needs to be asked, who is taller relative to the rest of the members of their gender, okay? So is it going to be the 73-inch tall man or the 68-inch tall lady, okay? So we're going to have to do this thing with what's called a Z-score, okay? So what the Z-score does is it tells us how many standard deviation chunks the value is above, okay? Now, concept here. I'm going to draw the picture and I'm going to shift us over. Okay? So, you have this idea of this bell curve. If a value was located right here, okay, this would have a Z-score of 1 because it is one standard deviation set or chunk above the mean, okay? Now, something that would say right here, this would have a standard or a Z-score of negative 1.5 because it is, let's see if I can pull it up here, 1.5 standard deviations below the mean. So if a Z-score is positive, it's above the mean. If a Z-score is negative, it's going to be below. And it gives us an idea of position. Where is it on this scale? Okay. So now, in order to find this, X is your value, mu is your mean, and sigma is your standard deviation. So, if they tell us that the mean is 10, the standard deviation is 4, they want us to find for the value 0, okay? And this is number 1 coming off of the worksheets, okay? So, X is my value. So this is going to be 0 minus 10 over 4. So 0 minus 10 is going to be negative 10 over 4, which is going to be negative 2.5. Now, they also ask, what about the value 11? So it's going to be 11 minus 10 over 4. Okay, so we're just plugging those in nice and straightforward. Okay. Now, the other thing that they can ask, what value has a z-score of 1.75? Okay. Now, formula-wise, they are giving me z. So I have 1.75 equals, I do not know x, but I still have a mean and a standard deviation. So we're going to start by multiplying by 4 on both sides, and that's going to kick that away. Okay. Then we're going to add 10. So it's going to be 17. Okay. So if you plug 17 back into your formula up here with the 10 and the 4, you would get that 1.75. Okay. So back to our PowerPoint. Okay. So combining the idea of z-scores and the empirical rule, if you have z-scores that are between -1 and 1, that is your 68%. Between -2 and 2 is 95%. And all or almost all will be between -3 and +3 on your z-scores. Okay, and that's just combining those two concepts. Now, the next thing is we're going to talk about quartiles. Okay, now for quartiles, Q1 separates the lowest 25%, because we are separating it into quarters, from the rest of the data, which is going to be the upper 75%. Quartile 2 separates the bottom 50% from the upper 50%. This is also the median. So Q2 is your median. And then Q3 separates the bottom 75% from the upper 25%. Okay? Now, the way this is going to be done, guys, it is the same concept as if I was going to take a like a big log of like cookie dough, and I wanted to separate it into quarters. Okay. What's going to happen here is you're going to cut it in half. And then we're going to find the median of everything below that. Okay, so we're going to find the median of this lower kind of half, and that's going to be 1. And then we'll find the median of our upper half, okay, going upwards. So it talks about put it in increasing order, okay, and then we're going to find the values, okay. So let me go back. Let me stop the share here, and I'm going to put a data set up, okay. And I'm going to go ahead and put this data set in order, okay, so that we're not having to fuss with it, okay? So, get this down here. Oh, Hang on, y'all. For some reason, my phone decided to drop. Okay, hang on. I'm trying to come back. Okay. Okay. Hang on, guys. I'm trying to get back. Hang on, guys. I'm trying to get back. I'm trying. Okay, can we hear me now? Awesome. Okay, we're back. Okay, so here is, and I'm gonna try and bring this across. Oh, this is gonna be really hard. I'm gonna have to hold this. Okay, so here is our data set. Okay, so we got a bunch of 3s, 4s, 5s, 6s, 7s, 8s, 10s, 11s, 13s, and 26. Okay, so now I'm going to find the median of our data set. Okay, so I'm going to work my way to the center. Okay, it's going to get right between these two. So 5 plus 6 divided by 2 is 5.5. That's my median. That is also Q2. Okay, so now I need to now do the median of everything below. So that is going to be all of the 3s through all of the 5s, since this median is above that. Okay. Okay. So this one hits right between there. So it's going to be 4 plus 4 divided by 2. It's going to be 4. And that's going to be Q1. Okay. So again, all I did was work and find the median of that lower set. Okay. Now, hopefully you'll be able to track better with this upper one. So I'm going to work this upper side. Okay, it's going to hit right between these two. So 8 plus 8 divided by 2 is going to be 8. And that's going to be Q3. Okay, so again, concept here is I took the whole data set. We went to the middle and cut it and found our median. That is Q2. Then we took everything below the median. Okay, now, if the median had been one of the values, so let's say it had been this number 5, then I would have looked at everything below that. Okay, so if it had been this very last 5 right here, I would have looked at from this 5 downwards and done the median from there. Same gig on the upper half. Okay, so there's that. Now then, you can also put this same data set unordered. Okay, now that's the only kind of advantage is I would not have had to have put this in order in my calculator. You can put it all in that same L1 spot and then do your 1 var stats that we did earlier. And remember, when you scroll down that list, it would give you Q1, the median, and Q3. Okay, so it would give you that through that data set. Okay? So now, the concept here is when you do the data sets, and this is by no means, this is not that same data set that we just had. The concept is if you find the median and then your first quartile between your smallest data point and that Q1 value, that's about 25%. The next 25% sits between Q1 and the median. The next 25% is going to be between the median and Q3, and then the last one. So on this particular data set, they're talking about the rainfall in Los Angeles. We see that the this first quarter is really kind of tight packed, and this last quarter is really kind of spread out. Okay, so this also kind of helps us visualize what's going on with our data. Okay, now another thing that we can be asked to do is find percentiles. Okay, now one of the things that people oftentimes get wrong with this, okay, the higher the percentile, the higher the value. So if you're going to talk about, say, SAT scores, and you had a really high SAT score, okay, you were up there in that very high values, in the 1500 or whatever, your percentile is going to be like in the 95th or 96th percentile, because that says you did better than 95 or 96% of the people who took the test. Okay? People will oftentimes say, I'm in the 3rd percentile. Okay, that's really bad, because that says you did better than 3% of everybody else. Okay? That is not a good place to be in. Okay? It is not a good place to be in the bottom grouping. Okay? So if you're trying to be in the top end of something, you want to be in those top percentages, percentiles, 97th percentile, 99th percentile, stuff like that, okay? Because if you say you're in the 5th percentile, then you're in the bottom, okay? So that is one of the things that students miss quite often, okay? So now, in order to find percentiles, okay, what you're going to do is you're going to have to put the data in order from least to greatest, okay? And then you are going to take the percentile and divide it by 100. So basically get it in its decimal form, and you're going to multiply by the number of data points, okay? Now, one of two things is going to happen. If the answer that you get is a whole number, you are going to count to that position. So you might get that is supposed to be the 12th value. You're actually going to go to value number 13, because you need to make sure that that percentage, whatever percentage they were looking for, is under. Okay? Now, if it's not a whole number, just go up to the nearest whole number, and that's going to be your value. Okay? So let me show you how to do this in a data set. Okay, so I'm going to put a data set up underneath our setup, and then we're going to talk about how to find percentiles. Okay, so I'm going to put the data set here. Okay, hopefully y'all can kind of see. I don't want to get rid of this other data set that I have underneath it. And I'm going to talk about what's here in the stuff, okay? So we have this data set. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 items per row, and 1, 2, 3, 4, 5. So there are 60 data points here, okay? So they want us to find the 78th percentile. Okay, so what we're going to do, put this in decimal, and we're going to multiply by 60, which is the number that's in here. okay? And I get 46.8. So I need the 47th value. Okay, so I need the 47th value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 24, 25, 26, 27, 28, 29, 30, 31, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47. That is the number 52. Okay, so I went to the 47th value in the list, which was this value of 52. 52 is the 78th percentile. 78% of the data is before 52. Okay, so again, 78% of my data is before the value 52. Now, the next one asks us to do the 41st percentile. Okay, so again, we do it in decimal, 0.41 times 60. Okay, so 0.41 times 60 is 24.6. So I need the 25th value. Okay, so 1, 2, 3, that's going to be 12, 13, 14, 15, 16, 17, 18, 19, 20, 22, 24, 25. So it happens to be the number. Now, it is coincidental that it is the number 25. Okay, that is entirely coincidental that that is 25. Okay, now I'm going to slightly change this next one. Okay, I want us to do the 12th percentile. Okay, so 0.12 times 60. Dang it, that's not right. Let me change this. 10th. Sorry. Trying to make this come out to be nice and even. Okay, that's going to be 6. This is a whole number. So you're going to go up to the 7th value. So 1, 2, 3, 4, 5, 6, 7. The value 8 is the 10th percentile. That means 10% of the data, 1, 2, 3, 4, 5, 6, that's 6 numbers, is below the number 8. Okay, so you've always got to take, if this comes out to be a whole number, you need to go up to the next position when that happens. Okay, so hopefully that kind of makes sense for that. Okay, we go back to our PowerPoint. Okay. Okay, now, if you are having to work from a data set and they're wanting you to figure out percentiles, what's going to happen is you take its position, or you take the number of values less than that, and you're going to add 0.5. And the guys, this is to get you off the line. Okay, so for example, if we were going to do, I'm going to pull this data set back over here for us. Okay, and come back out to the screen. So give me just a second. I'm trying to get rid of some values here. Okay, so let's say that I wanted to figure out what percentile 19 is at. Okay, so 19 is what percentile? Okay, so I'm going to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So it's the 19th value, or sorry, it's the number that are below it. So 18 numbers are below it. Again, it's coincidental. Plus 0.5 over 60. So 18.5 divided by 60 is 0.308. So we would say 31st percentile. Okay, so again, 19 was the 19th number that is coincidental. There are 18 values below. So there were 18 values below 19. We add a 0.5 just to make sure that we're not going to land on something funky. Okay, and then we divide by the total number of values that are in the setup. Okay, and then round appropriately. Okay. So here we go back to our level 3, level 4. Okay. Now, sometimes they're going to ask you for this thing called a 5-number summary. Okay. Okay. And in order to do that, you're going to need your minimum, the first quartile or Q1, the median, the third quartile or Q3, and the maximum. Now, guys, this is the last 5 numbers that one bar stats gave you. Okay, this is the exact 5 that it does. Okay, so now we're going to talk about, okay, because sometimes they'll ask you to do what is a 5-number summary, and so they're pulling that information. Now, one of the other things that we're going to talk about is this thing called outliers. Okay, now here is the concept for outliers. Okay, we need a way to mathematically decide whether or not something is too low or too high. Okay, so these are considerably larger and considerably smaller. Some of these come from errors, like I didn't put a decimal place in. Some of them are correct values, but they just are extreme. But the question is, how far out are you allowed to go? So let's go back to childhood for a minute, okay? And let's say that you had friends that lived in each house going beside yours, okay? So your house was at the center, and you had friends that lived in 4 houses, each of the 4 houses to your left, and each of the 4 houses to your right, okay? Now, Mom, if she stood out in the front yard, could see 2 houses down and could see you playing, okay? So let's say that's Bob's house and Alan's house, okay? So we're not concerned with the people that are like your next door neighbors on each side. So, but Mom can see down to Bob's house that's 2 away and Alan's house that's 2 away, okay? Now, if Mom is anything like me, Mom's loud. So Mom could yell and you could still hear Mom at the 3rd house away. So the one that was next to Bob's, okay? So let's say that that was Charlie, and on the other side of Alan lived John, okay? So Mom could come out and she could yell and be like, hey, it's time to come home, whatever else. And as long as you were at Charlie's house or John's house, you could still hear Mom. Mom's willing to let you go. Even though she can't see you at Charlie or John's house, she's still willing to let you go down to Charlie and John's house to play because she can still get a hold of you. Now, you become an outlier when you go past Charlie's house or past John's house, because now you're outside of where Mom can see or yell and she can be heard, okay? So the question is, how do we mathematically set up how far out it is to Charlie and John's house, okay? The first thing that we're going to need to figure out is what's called the interquartile range. Now, the interquartile range is you find Q3 and you subtract Q1. So it's that inner 50%. Okay? This would kind of be like how far it is from Bob to Alan's house. Okay? Kind of look at that range. Now, what we then do is we take that inner quartile range and we're going to multiply by 1.5. Okay? What we're going to do is we are going to subtract that off of Q1 and we're going to add it onto Q3. Okay? And this is going to give us the edges. Okay? Now, this is now going to give you out to, it's going to basically imply how to put this out to Charlie and John's house. Okay? So, we're going to go back to this data set that we had before. Okay? So, I'm going to get rid of this up here. So, this was our data set that we had before, and I intentionally left all this information up here. Okay? So the first thing that we're going to find is that inner quartile range, which was Q3 minus Q1. And that is going to be 8 minus 4, which is 4. Okay? So now we're going to do 1.5 times that IQR, which is going to be 1.5 times 4, which is 6. Okay, so now coming back down into our data set, our lower fence is going to be at our Q1 value minus this number up here. So I've got 4 minus 6, which is going to be negative 2. Now, the upper fence is going to be at Q3, which is 8, plus that 6 number that we had. And that's going to be at 14. Now, any data points, and I'm going to kind of slide this down and move this up, okay? Any data points that are lower than this, okay, is an outlier. Now, our data set went as low as 3, so we're good on this lower fence. Now, any data points that are higher than this upper fence are outliers. 26 is higher. So that means 26 is an outlier. Okay, so again, this lower fence that we had over here, that's like Charlie's house. You can't go past Charlie's house, otherwise you're considered an outlier. This upper fence is John's house. If you're past John's house, you're an outlier. Mom's going to be mad if you're an outlier. So looking at our set, 14 would have hit here. 26 is an outlier. Negative 2, though, on this other end, all of our data stuff was inside of that fence, okay? So this may have been that they didn't even make it past Alan's house over there, or Bob's house, whichever side that was, okay? So that's how we find those, okay? So okay. Now, we'll go back to our problem. Okay, now, box and whisker plots, or box plots, okay? And I'm going to do one for this other data set, so I'm not going to quite get rid of this data set for us yet. Okay, a box plot presents the 5-number summary along with some additional information. Now, there are several types. This particular book, or yeah, this particular book does what's called a modified box plot. Okay? And what you need to know about the modified box plot is that you go to the lowest data point inside of the fence, okay? And you go to the highest data point still inside the fence, okay? Now, here's the deal though. That's where these outside little lines are. Now, the stars out here would be outlier stuff. Now, this stuff in here, this is going to be Q1, Q2, and Q3. So the box is going to be done with Q1, Q2, and Q3. Okay? So I'm going to pull back to our screen over here, back to our whiteboard. Okay? And I'm going to make this happen. So first off, here's the number line. Okay? So 0, 5, 10, 15, 20, 25, 30. Okay, I don't really need this. Okay, so now, remember that, right down here, Q1 was at 4. I'm going to come back up here, and I'm going to put a line at 4. Now then, Q2, or the median, was at 5.5. So I'm going to come back up here. I'm going to put another line at 5.5. And then Q3 was at 8. So I'm going to put another line at 8. And I'm going to box that together. Okay, so there's my box. Now, that whisker, I'm going to go. I need my lower fence. My lower fence is at -2. I need the lowest data point inside the fence. So it's going to be here at 3. So I'm going to come back up here. And I'm going to put a little line at 3 and connect it back to the box. Now, up here, my upper fence was at 14. So I'm going to the biggest data point inside the fence. And that's going to be here at 13. I'm going to come back up here. And there's my spot at 13. Sorry, put that glare off there. Now, 26 we said was an outlier. So I'm going to put a little asterisk point up there at 26 to show that that is the data point that was considered an outlier. Okay? So, again, this is called a modified spot. Okay, so again, what we did here, let's see if I can label some of this for you guys. Q1, Q2, which is also the median, Q3. Okay, this is largest inside the upper fence. Okay, this one is the lowest inside the lower fence. Okay, and I'm going to move that over. Okay, and then outliers are done with stars. Okay, and guys, if the outlier's below, then you would have put an asterisk below. This one we happen to have an outlier above. Okay, and again, this is a modified box plot. Okay, so you're going to have to do all of that IQR and the fence stuff, finding the value for the fence, and then your lower and upper fences before you can do that modified box plot. Okay. Now, box plots are helpful because you can kind of tell whether or not a data set is skewed one way or the other based on it. So, for example, this one is very, very similar to the one that we did. And we noticed that this right side whisker line, or the line coming off the box, is a lot longer than this one. We also have this side of the box is bigger than this one. So this makes us think that we have a lot more data values to the right. So this is skewed right. Okay. Now, if the box plot, so for this one, we see, again, this longer line towards the left-hand side. We've even got a couple of outliers out here. This side of the box, this left side of the box seems to be a little bit bigger than the right-hand side of the box. This is all kind of implying skewed left. If it's all pretty much the same, like if both sides of the boxes are pretty even, you've got kind of the same length of whiskers on both sides, then it is considered symmetric, okay? Now, I did not do every single example through this. So do go take a look at the other examples, especially the keyed set, so that you can see. I did do another couple of Z-score problems, and I did another one of the, there's a box and whisker plot, and I talk about how to find the values and how we get up with the outliers and stuff like that as it's processing, okay? So let me stop the share on this. Okay, and then gotta switch this. Okay, hopefully now you can see me. Okay, hopefully now you can see my face for what's going on with this. Now then, let's talk real quick in the little bit of time we've got left, okay? First off, let me double check this. Can you see me now in the video? Okay, awesome. Thank you, Terry. Okay, so we are going to have a test next week. Now, before we all start having like the, oh my goodness, moment. Okay, now, number one, I will be providing lots of formulas to you. Okay, pretty much if it wasn't regular, mean, and I mean like add them all up and divide by the number that's there, median, or mode, or range, okay, kind of the traditional ones, I will pretty much give it to you. So weighted means, mean from a frequency distribution, standard deviation, both population and sample, variance, all of those kind of things, okay? I will be providing those formulas for you, okay? So please do not think that you have to like memorize all of those formulas. I will be providing a lot of those formulas for you, okay? Because my expectation is that you understand which formula to apply in what scenario, okay? Now then, there is going to be a test review that is going to open up. It is going to be classified as an other assignment or an other category. Now, this, yes, you will need a Scantron. Now, this review, number one, it is a beast, okay? And I do not expect you to do that review in addition to your homework, okay? This review is there so that if you want to go back, because pretty much this review is, I just lumped everything out of chapters 1 through 3 together, okay? So it is there so that you can, if you want to go back and look at some of the stuff from like chapter 1 or chapter 2, that those homeworks may not be open anymore, you can go back in and practice. It has all the same helps that you would have in a homework session, okay? It will have ask my instructor, show me an example, take me to the textbook, all those kind of things will still be in there. And so you have all those same helps. The review is not for a grade, Okay, so please hear me on this. The review is not for a grade. Okay, so you can do as little of it. You can do 1 problem, you can do 5 problems, you can do no problems, you can do 20 problems. It's however much you feel like you want to go in and do. You can click around. So if you want to do question 1 and then you jump over to question like 37, go for it, okay? You do as much or as little of that review as you want to. It is not for a grade, okay? And it is going to be classed as an other, okay? Now, what we'll be opening up tonight is 3-2 and 3-3. And those will have your 7-day time frame on those. Now, for the review, for test next week, we will still do review for the first 30 to 45 minutes, and then you'll have the remainder of the time to do your test. Remember that once you're done with your test, you're free to go for the night when you turn your stuff in. So you will need a Scantron because there will be a multiple choice portion of the test. There will also be an open-ended free response section to this test, okay? So you will have to do both. For the free response section, you will just answer in the test or on the test, and I will grade it directly on the test. So you'll have a Scantron portion and then the free response portion. Again, the review is not for a grade, okay? I also did record this session tonight, and I will be posting a link in Canvas as soon as I have this finalized and uploaded. It will have to go onto YouTube just because of the length of the recording. For anybody who either maybe you got on here late or maybe there were some technology issues or you just want to go back and re-see how to do something, okay? So I will be posting that as soon as I am done with this and once I get that all finalized, okay? Are there any questions? Okay, if there's no questions, then I am done with you for the evening. And I will see you guys next week. We will be back regular class next week. Okay, so I'll see you guys next week.